Okay, so this is a solution to question 1 from the assignment. You look at what I've done here. I drew the original picture from the question, and then I've drawn a simplified version of the picture showing the forces that are acting on the mass. Now, the mass is 25 kilograms. We have, let's use my pencil, it's a little thinner. We have the push force pushing upwards. We have the normal force acting perpendicular to the surface. And we have the gravitational force. But there's another force as well, and that's friction. Friction could be acting upwards or downward, depending on which way the box is trying to go. Now, you're trying to find the minimum force that you need to apply to keep the box from sliding down the hill. Presumably, that means the box is trying to slide down the hill and friction is on your side, working with you. So we're going to make the assumption that the friction force is pointing upwards. So here's what that diagram would look like. On an angle, we have our angle of 19.6 degrees. We have the mass. We have gravity pulling downwards, which has a component this way on the ramp, Fgx, and it has a component this way, Fgy. We have the push force pushing upwards on the ramp, parallel to the ramp. We have friction also pushing upwards. And we have the normal force. Let's draw a little divider there so we can see the difference. So we have the normal force pushing perpendicular, and we have the y force for gravity pushing perpendicular and nothing else in the perpendicular mode. Now, if we want to figure out what force Fp has to be, we have to reach a point where these three forces, Fgx, Ff, and Fp, are in equilibrium. Any force bigger than that will keep it from sliding down the hill. So now we're going to draw the x components of all of our forces with the page or the frame of reference rotated. So now we've made the ramp horizontal. So our x direction, and we'll call this positive x to the right. X direction, we have push force, which we want to know. We have the friction force, and we have Fgx acting in the opposite direction. To get an idea of what each of those values or each of those forces is equal to, or means if you want. Fp we already know, we're trying to figure that out, or we already know what we're trying to do there. Fgx, the next easiest one to figure out, is going to be Fg, and we already worked out that that's sine theta, where theta is that angle, 19.6 degrees, the angle of the ramp. And the force of friction is equal to mu times the normal force. So now we need to draw a picture, and I'm just going to do it right here before I go back up to continue the next part. We need to draw a picture of the vertical forces because we've got to figure out what Fn is. So Fn is pushing upwards in the y direction on that axis. So this would be y. And the only force other than that acting in the y-axis is Fgy, which is equal to Fg cos theta. And since we know that the mass is not accelerating this way or this way, it's not accelerating perpendicular to the ramp, these two forces must be equilibrium, so they must be equal to each other. So Fn is equal to Fg cos theta. So now we can bring that back over here and say mu, by the way, that's mu s, Fg cos theta. So here's our free body diagram where we can figure out what Fp is. We know we're aiming for a minimum Fp being the point where all of these forces are in equilibrium. So we can write that out as being Fg sine theta is equal to Ff plus Fp. But if we rearrange that, we get Fp is equal to Fg sine theta minus Ff. So that's what I'm going to write. Fp equals, and I'm going to change Fg sine theta to be the mass times gravitational acceleration times sine theta minus mu s mg for the gravitational force cos theta. Of course, we can factor one thing out of there. G is in both. Actually, we can factor m out of that too. Yes, we can factor m out of that too. So we can write mg, which leaves us inside with sine theta minus mu cos theta. And that essentially is the final equation before you have any data. We plug in the data, and we know we're going to put 25 times 9.8 or 9.81 times sine 19.6 minus mu cos 19.6. And at this point, you plug in your value for mu, do the calculation to get your value for Fp.